In this video, I'm going to show you how you can troubleshoot and repair your top loading washing machine. In this case, it is a General Electric. Now, if you have a different make washing machine, the troubleshooting procedures outlined in this video should apply. They're all very similar. Now, the problem with this particular washer, once the tub fills with water, the motor does not come on to start agitating. I do hear a hum, but there is nothing else happening. So we're going to find out why that is the problem with this particular washer, and we are also going to go over a lot of troubleshooting procedures for the different components inside of a washing machine. Now, because there is a hum coming from the motor, I could more than likely rule out the lid switch, because if the lid switch is working properly, you would not hear a hum coming from the motor. Now, to get started, we're going to have to disassemble the washer, and that's easily done. On the back of the control panel, there's a bunch of screws, as you can see here, along the top. There's 4 along the top edge, and then there's a couple down the sides. Each machine will vary where the screws are located. Now, to remove the whole upper panel of the washing machine, you're going to slide the entire top of the washing machine forward towards you where you're standing, and then you're going to lift up on the rear, and that's how that releases. After this has been freed up, then the next thing to do is to release the front panel here, pull that side off, and the same on this side here. You're going to pull this forward. Once this panel is removed, then we could remove the top. Alright, so now the front panel is undone. You grab this, pull forward, see the side, and you should lift up and out. And now you have access to the entire compartment here. These are the components you should see. If you have a General Electric, a lot of other models will be very similar. Here is your capacitor for the motor, which is located at the bottom. Over here to the right, that is your pump to pump all the water out of the washing machine tub. And that's where the power goes in. There's 2 leads for 120 volts. Over here is where the tube goes to the water level switch. Now, how this switch works, it works on pressure. Once enough water is inside this tank, it exerts a certain amount of pressure inside this little housing you see right there, and that pressure pushes inside of this tube, and then it goes up to the level switch, which you see right here. There's the tube. Now, because this particular washing machine fills with water and then it does not start up, but I do hear a hum, the first thing I'm inclined to check would be the motor at the bottom to make sure it's not seized. And the way to do that is to locate the shaft, which is right down here. There's a pulley and there's a shaft attached to it. And you can put pliers on the shaft of the motor and see if it moves back and forth freely. If it moves back and forth freely, then you should not have a problem with the motor's shaft being seized. So let me grab a pair of pliers and take a look at that first. Alright, I have the camera in position. It's kind of dark in there, but there's the pulley with the belt. You want to put the pliers on the shaft going to the pulley. I'm going to take a pair of channel locks. We'll put it like this. Squeeze it nice and tight and make sure that moves. Now, in this case, it's frozen. So that's a good sign. That means the problem is the shaft on this particular motor seized up from sitting around for a few months without using it. So I'm going to wiggle it back and forth to try and free it up. And you just heard it. It is now free. It's as simple as that. Look at that. We're good to go. Now, if you're not that lucky to have such an easy fix like that, then there's other things we can go over. I'm going to go over that next. It's also a good idea when you're done doing that to put a few drops of lightweight machine oil right on the end of the shaft right here. Let it flow around. Don't get carried away, just a little bit. Now I'm going to try it to see if that was the problem. It should be. If it runs good, we'll go over a few other things to help you if your problem is not a frozen pulley. you go. Back to normal. Alright. So this took care of my problem. Now if that wasn't the problem with your motor, we are now going to check the capacitor and then the windings on the motor itself, as well as a few other things. We're also going to go over a bunch of other components on the washing machine to help you troubleshoot other problems you may be having with your washer. In the event that your shaft is free and you still hear a humming coming from the motor, the next thing you're going to want to check is the capacitor. The capacitor is located inside the compartment. It's going to look like this, a round can or possibly an oval can. Now make sure your plug is unplugged before you touch the capacitor. The first thing you're going to do is, if it's insulated like this, just grab it and pull down. Do not touch these terminals after you remove the clips. There's high voltage inside this capacitor and it can be deadly, so make sure you grab this with a pair of pliers to pull them off, but just do not touch the blades. Pull down. Now the average person is not going to have a resistor laying around, so the next thing you could do is you could take a regular lamp like you see here. Alright, take a lamp and make sure it's already turned on, and then you unplug it from the wall, and then you bring the lamp over to the capacitor and you could put the blades between the capacitor. When I connect this between the two terminals, what's going to happen, any charge that's remaining in the capacitor will be discharged through the incandescent bulb in this lamp. So I'm going to touch this to the two terminals. I'll hold this at an angle, maybe you'll see a flash with the light, but I'm going to show you what's going to happen when I connect. Watch. Alright? That's what you want to avoid. You want to drain that down. So this is a good way of discharging a capacitor. Just throw a 100-watt bulb in a lamp and do that and you're good to go. So now this can safely be handled. But before you touch this capacitor, take a pair of lineman's pliers or any other pliers that are insulated, and you want to go between both terminals to make sure they are shorting against each other. You will know there's no more dangerous current being stored in that capacitor, and then you can carry on with the tests. So what we're going to do is put the meter to the 2 megohm range or higher, and then check across the capacitor terminals. The reading should start lower and then move higher. Alright? If you don't get anything, spin it around and check this way. And you can see it's shooting up higher. It started lower and it goes out of range. That's a good capacitor there. So you can see the resistance started lower and then it moved higher out of range. So that's a good test for that. You also want to go to a lower setting, as low as you have, and you want to check between the terminals to make sure they are not shorted. You could also use a continuity setting. You do not want a short circuit between these terminals. Nothing should happen. Spin it around, check this way, and nothing happens. Now also, put it back to the high range, 2 meg or higher. It could be 2 or 20 or 10 meg. When you put it to the 2 meg setting or higher, you want to put one terminal to the metal can, scratch it good, and touch from each terminal. And that meter should not move. If it does, you're going to discard the capacitor. There should be no connection between the terminals and the can. So those are the 3 tests you should complete. Now if the capacitor test's okay and the motor is not seized, you could also see the windings in there, that they're not burned. They should be shiny copper. The next test would be to remove the harness on the motor. Alright, remove that. And there's a bunch of terminals inside that boot right here. Every machine is different, so it's hard for me to tell you what exactly to test. Now, inside the washing machines, a lot of the time, you're going to find a schematic like this that's folded up. And you can take a look at it, and you can see right here, shows the start winding. You're going to have a red wire, and as you can see here, there's the red wires going into the capacitor. And then we have a red wire right here, which goes all the way down to the harness into the motor. So you see it says R for red. That goes into the motor where the start winding is. And then you have VW, which is violet with a white tracer. That is the other side of the start winding. So you'd want to do a continuity test across the start winding. So you look over here. There's a violet and white right there, and that's the red. So the terminals on the motor that go where this red wire is and the violet with the red, you would do a test on using a low ohms range. In my case, I have 200 here. In this case, I get around 8.1 ohms, which is fine. Now the next thing, here's the motor. All right, so that's your start winding. I have a wire here, which is N. N comes up as dark blue. So I want to do another test now for the motor. So I have the start winding, and this is the motor. Now if you have 2 and 3 speeds, you're going to have to look at the schematic and check each speed to make sure it's right. In this case, it's a fairly simple one. There's not too many wires to check, but some of them you're going to have multiple connections here. So you're definitely going to want to have the schematic, which is usually inside the washing machine itself. Now to check the motor itself, N is a dark blue wire, navy, and yellow. So I want to check this winding in the motor. So between the dark blue and the yellow on the motor here, I would test. Now when I test the dark blue terminal and I test the yellow terminal, I get 2.6 ohms. So that's another good reading. So at least I know that I can rule out the windings in the motor as being a problem. So I could plug this back in. The next thing you're going to want to check is the lid switch. If that's faulty, the machine will not come on. You're also going to want to make sure there is power being supplied to the motor, and that's coming from the timer control. So we would have to check that also. So let's take a look at that. Now to test the lid switch, it's very simple. You're going to look for the harness, like you see right here, that goes underneath the top lid and heads to the switch. Now, you could do that by lifting this up, and then you can see exactly where it goes. There's the orange right here, this wire, orange and white. It hangs down, and then it goes to the lid switch. So I'm going to disconnect this harness. You see right here, squeeze it and separate it. And inside the harness heading to the switch, you're going to put your digital multimeter probes inside these terminals, set the meter for a continuity setting, and you're going to open and close the lid. You should have 0 ohms, and then it should be infinity. So if you have a continuity alarm, you should hear it beep and go off, beep and go off when you open and close the lid. Now in this case, the switch is activated and deactivated using a magnet, and some of them will use just a hole with a protrusion that goes into the hole, pushes on a little plate that activates the switch, opens and closes it. So as you're checking for continuity, listen for the beeping, and then listen for the beeping to go away as you open and close the lid. It's very simple to do. That will rule out the lid switch as being the cause of why your machine is not starting to agitate. Now in order to test the water flow valve or the solenoids attached to the water flow valve, what you're going to do is just going to slide off the connector with the plug disconnected from the wall, no power to the washing machine. Take your digital multimeter. You could put it on a range that goes up to around 2,000 ohms. Place one probe on one terminal and the other probe on the other terminal. and observe your meter. And in this case I have 1.12 k ohm. That's fine. As long as you're in and around that range, a little lower, a little higher is fine. If you don't get a reading, that means the winding is open, it is faulty, and you must replace it. Repeat this test for the other one over here, and you should get around the same readings as well. After doing this test, if you still do not have water when you put it on the proper setting on the machine and then turn on the cycle, you may want to put your probes on an AC voltage range and probe these two connections here to make sure that you are getting power to the solenoid. If you're not getting power to the solenoid, then the next thing you're going to want to test is the level switch, and that is right here. Now this switch works on pressure. This tube goes towards the bottom of the tub, and the more water you place in the tub, the more pressure you have on this line acting on the switch. Now one lead is power going in, and then you have two other connections here. Some are designed that the power goes in the middle, and then the other wires on the end are the ones you're going to want to test from the middle. You would check from the middle to the ends, and in this case the power comes in on the right side here, so I would pull this off. Once that is pulled off, with no water in the machine, you want to check between the power lead going in and each terminal. You would place your digital multimeter on a continuity setting or a continuity alarm. You would place one probe where the power enters the switch, and then you would check from the power entering the switch to each terminal. When there's no water in the machine, between this terminal and one of these pins, you should have continuity, and between the other pin, you should not have continuity. When the tub has water in it, then that should reverse when you do the test. The one that had no continuity should have continuity, and the other one should not have continuity. If after testing the switch, you see this does not work, make sure the vinyl line is not cracked or has any breaks between the switch and where it attaches to the tub, because if there is, it will not work. You can replace this tube very simply by going to a hardware store or a home improvement store or any plumbing supply. It's just a piece of vinyl. Once you've confirmed that's not a problem, that leaves the temperature switch, which is right here. You could take your probes. You could check the switch using continuity between the terminals by rotating the switch, make sure it goes on and off. You could leave the unit plugged in and without touching anything, place one of the meter's probes on the metal chassis, and you're going to touch each one of the terminals on the switch to verify there is power going to that switch. If there's no power going to the switch, that's a problem. Once you verify there is AC voltage between one of the terminals and the metal chassis of the washing machine, you can then rotate the switch and see if that voltage moves around between different terminals. And you could also do continuity tests between the terminals to make sure they are switching on and off. If everything you see here tests okay, and your lid switch is definitely good, and you do have full power, then you absolutely have to expect that your timer control is faulty. Now there are tests you can do, but each unit has its own schematic for the timer, so that's not something I'm going to get into, but you can look at the schematic, and it shows you when the dial is in a certain position, which one of these numbers pins connects together. So you can verify that the pins are connecting internally in this switch. Also very important, if you're having a problem with your washing machine not operating properly, you also can check that the neutral and the hot from the wall receptacle are flowing into the timer control. In this case, the white with the red and the red are power. So you can pop the harness off, use your digital multimeter, and probe those two connections to make sure there is power at those terminals. If all that tests okay, then more than likely your timer control is all that is left. Now if you'd like to test the pump, that's fairly simple to do. This is the pump right here. You would slide this off the terminals, Take a reading with your digital multimeter, set it to a low ohms range. In my case, I have mine set for 200 ohms. Take a reading between the two terminals, and in this case I get around 11.1 ohms. Yours should be in and around that area. Now you can also check by putting your digital multimeter probes into this harness and setting your meter to an AC voltage range. I put mine on 200 volts AC, and then I would just put these two probes into the harness and advance the timer control to where the machine would normally drain. I should see 120 volts show up on this harness. If you do have power and this does not turn, even though the terminals give you a good reading, it's possible the pump is seized. You could try taking it apart to move the shaft around to free it up, or you could just replace this pump. If you would like to disassemble the pump, it's pretty easy. There's only a few screws that hold it together. This is the way it was. You take the screws off, this pops off. There's an O-ring here. Just make sure it's not dried out and cracked. If it is, replace it. When you go to reassemble it, just put a little bit of silicone grease around the whole O-ring. This part here, this was inside here. It slides all the way in. This is a waterproof compartment. You could put a little bit of silicone grease in here when you slide everything back. And there's also a O-ring type of a seal right here. Put some silicone grease on that. Sometimes you have debris on this part here. This is a magnet. Half of it is magnetic north and half is magnetic south. You don't see the line where the two come together, but that's the way it's designed. And that slides right inside here. You push it all the way in. It'll pop in like that and just push it till it snaps. Now the other side here, I'm going to slide this off. This is where the winding is right here with the two terminals. This whole piece here slides off of this part here. So let me do that. Once these two slide apart, you'll have the pump assembly with the impeller separate from the windings where the power will be applied. And it works pretty simple. There's a bunch of windings wrapped around this laminated iron core, and you get an alternating magnetic field here. And this part here will go right inside of it like that, through the plastic of course, and then this will spin with the alternating magnetic field. So you could take this all apart and make sure everything's clean if this doesn't rotate freely. If it does, then leave it all alone. That's how you take this apart. If you enjoyed this video, please rate it a thumbs up, subscribe, and post links to this video on other websites and blogs. Thank you.